Hello. This one is going to deal with conservation of mass. You're going to use some very simple, easy to purchase. Hopefully you have a triple beam balances, a couple of them. You have graduated cylinders, and hopefully some type of flask, the Erlenmeyer flask of this shape that kind of helps with the material. The first, if you can pan down, please, Ms. Amy. On your sheet, this is what students will get, and it walks them through. It talks about law of conservation of mass again. It shows them how to work through a chemical equation. You're going to have water and Alka-Seltzer, and then mixing that all together, you'll then show up with carbon dioxide, sodium hydroxide, and water, if they do it right. And it helps break down, again, the chemical equation, working through it. Do the numbers change during the chemical reaction, and those sort of questions. Proving that mass is conserved in a chemical reaction. That's what you're kind of working on. So you're showing a very simple version of the law of conservation of mass. What are your reactants? That, if they go back to the previous chemical equation, they should, if they know it enough about where the arrow stands. They work on predicting. Then they're going to go through some very simple steps, and then they're going to record their observations. To help with the setting up of this lab, I placed a couple triple beam balances out throughout the room. I then also, before class starts, I go ahead and crush up the Alka-Seltzer and give it to them in a baggie. It just takes, the crushing takes longer than I expected for the first class period, so the other class periods I changed that. And then using the graduated cylinder, they then get to practice their measuring techniques of water. But basically what they're going to do is they're going to take the Alka-Seltzer to put into the balloon. They're going to measure out the water and then put that in their Erlenmeyer flask. The tricky part then is to have them put the balloon filled with Alka-Seltzer on their flask. That's where they have to work with a little bit of teamwork. And then when they're ready, they're going to tip it and then watch the reaction. They're doing most of this part with the triple beam balance being used at the same time. So then you can watch for making sure that they're working on their measurements correctly. And then also just seeing if it changes once they tip their balloon up. Because then that shows you where the gas is being released back into the balloon. You still have your reaction happening down here with the bubbling. And they have to do a before where they have to measure the mass. They have to measure their mass before and after, and then to see if there is a mass difference. Most kids didn't get a difference, and if they do, then they did something wrong with either this, or they somehow did some spilling in this factor here. So, and that's a very simple, very quick. It doesn't take all period if you crush the Alka-Seltzer for them beforehand. And that's it for law of conservation of mass. Okay, so to show you walk you through the steps, your triple beam balance, put your flask on it, weigh it out.
It's so good for the kids to do trial and error.
Right.
Yes.
Where are we at? We're good? All right. Then they add their 20 mil, so they can record this. So you can have them write this down if you want. But again, it's just good practice to go through it. You then add your 20 milliliters of water. They can then notice the difference of how much water affects it. See if it goes anything with there. Nope. Then have them record this measurement. When you finally get it to balance out, I so badly want to grab it and make it stop wiggling. Okay, so what you can do is you can have them leave this scale as it is set up and very carefully have them lift off the triple beam balance so that when you're putting the balloon on, you're not pushing too much weight down on your scale. So take this off. At this point, you have a partner. The group holds, multiple people hold the balloon open. And then you have somebody else do the actual pouring of the Alka-Seltzer in your balloon. And then the tricky part is putting the balloon on your flask without pouring your contents out, and sometimes just having them hold the bottom works, and it takes them a couple tries. We're pros.
We're pros.
We're pros.
Science teacher pros.
And then before we have them tip it, we put it back on the scale, make sure it balances out again. You can see the balloon changes the weight, so you want to have them maybe make some adjustments. Really? You're gonna make me go all the way to the end,
I
aren't
was
you?
about to say, I think we're gonna have to go back to the end.
See how that's too heavy.
Well, let's see, that was not all the way to the end.
All right.
So maybe.
I don't have my nails anymore. Can't slide it over easily. We good?
Okay.
All right. Then you have the student assembly. Would you like to watch
Sure.
that happen? And they ooh and ah over the bubbles, and then have them watch carefully to see if there's any changes here. They start ooh and ahing over the balloon filling up. And then they go, oh, look, nothing. And you should, if everything is done properly, there should be very little change in your numbers when it comes to the mass.
Here goes the balloon.
Yeah, if they don't put it on far enough or tight enough, it pops off, and then you don't get your lab results. But this is a very simple, and visually you can see things happening, and that's what excites tweens. So,
And it really makes them think about the fact that a gas does have a weight. I mean,
Yeah,
like, you know,
there-
because they just don't think
you see
about
it
that.
here. Yep.
So it's very, represents the how the mass changes.
Yep.
The matter changes. Okay. Thank
That's it.
you. That's
Thank-
it.